Hello and welcome to Lesson 6.1, Introduction to Vectors. So please make sure you have a ruler on handy when you're doing these kinds of lessons, especially when you're talking about vectors. So quantities having both magnitude and direction are called vectors. So for example, 20 kilometers per hour going in a northwest direction is a vector and can be written mathematically. So I'm going to call it vector v is equal to 20 kilometers per hour. In a northwest direction, you usually put it in square brackets and you say its direction. We'll find out other ways to describe directions as time goes on. Whereas a magnitude only, so a quantity having only magnitude, are called scalars. So for example, instead of going 20 kilometers per hour northwest, you're only going 20 kilometers per hour. So that's a scalar. And a scalar can be written either as just a variable, let's call it s, or as the absolute value of a vector. So that's the difference between a vector and a scalar. We're going to be concentrating more on vectors throughout the rest of our course here, or at least part of our course. So some other examples of vectors are force. So for example, the greatest force on Earth is the force of gravity. Pulls everything down to the center of the Earth. There's also displacement, going from one point to another point in that specific direction. Any magnetic fields, again, the strongest magnetic field on Earth is the North Pole, and therefore helps pull things in that direction. Okay. Now, using this idea, we can look at what are called geometric vectors. Geometric vectors are represented by a head and a tail. So this is actually a physical drawing of it. And the length of the arrow is used to represent the magnitude or size of the vector. The way in which the arrow points describes the direction. These can either be described using their endpoints or by a variable. So example, let's say we're looking at 5 kilometers, the distance, traveling northeast. So I'm going to use my ruler right here. I'm going to draw a little Cartesian plane to start with. Northeast, well, this would be north. East is in this direction. So something going northeast is halfway between north and east, and it's only traveling 5 kilometers. So what I'm going to do is I'm going to use my ruler, and I'm going to draw something that is halfway between. Trying to use my ruler as best as I can. And this is going to represent 5 kilometers. Now, based on my drawing, I actually drew something that was based on the scale that 2.5 centimeters equaled 5 kilometers. So I drew something that was 2.5 centimeters long. Now I can describe this vector in terms of its size or its value. So I can call this vector v. So v is equal to the vector, that's 5 kilometers northeast. Or I can write it in terms of its endpoints. So starting point, let's call this point A, and this point B. So I could have also written this as AB, put a vector symbol over top of it, and it represents the same kind of thing. So we can represent it by just a variable or its endpoints. Okay, so some definitions. Two vectors are said to be equal if and only if the magnitudes are the same and the direction is the same. So let me show you an example here. So I'm going to draw a vector, just any size vector. I'm going to use my ruler here. Like so. I'll call this vector V. Now what I'm going to do is I'm going to move my ruler in the same orientation as it was before and draw something the exact same size. Headed in the same direction. Parallel, in other words. So, these two vectors, u and v, are headed in the same direction. They're the same vector, so what we say is u is equal to the vector v. Two vectors are said to be opposite if and only if the magnitude but point they have the same magnitude but point in the reverse direction. So, for instance, let's draw another two vectors. So this vector, I'll call this vector A, and I'll draw another vector the exact same size, just moved over a bit. A little lower, I'll call this vector B. So how we state that these are opposite vectors? Well, we use a negative symbol. So A is equal to negative B, headed in the opposite direction, or if you wish, B is equal to negative A. Parallel vectors only occur if they head in opposite or the same directions. Not necessarily are they the same size. So let me show you an example of that. So again, using my ruler, I'm going to draw a vector of a certain size. I'll call this M. I'm going to draw another vector, just moving my ruler over, but I'm going to draw the size much bigger. I'll call this vector N. Now how we describe these two vectors are parallel to each other. We can take the vector N, since it's bigger, is equal to some multiple of vector M. So I'm going to put K as some real number. Another way you can describe parallel vectors is the vector N is parallel to the vector M, and it doesn't actually tell you how much bigger it is or how much smaller one is compared to the other. And there we go. So let's give some examples of vectors that are equal. So we're going to draw two vectors that are equal for part A. They don't have to be in the same location. But they do have to be parallel to each other and the exact same size. So let's call these two vectors A and B. Here you see A is equal to B. Okay, for part B, parallel but different magnitudes. Okay. So in this case, you're going to draw something that's headed in the same direction, but not the exact same size. Could be in opposite directions, actually. So let's call this vector C and D. So vectors C and D are parallel to each other. Same magnitude, but opposite direction. Oh. Okay. Try some horizontal vectors here. So, same magnitude, but opposite direction. So let's draw something this size right here. Let's call this vector E. And exact same size, but a little lower and off to the side. Now it's headed in the opposite direction. So there we go. Again, E is parallel to F. Also E, its magnitude is equal to the magnitude of F. Okay, last one. Same magnitude, but not parallel. More challenging. So this was where your ruler comes in handy here. So draw something one size. So for me, I'm drawing this as 2 centimeters. So let's call this vector G. And something that's also 2 centimeters, but at maybe an angle or different direction, but it can't even be parallel. And I call this vector H. Here you can only see that the sizes of these two things are exactly the same. But the vector G does not equal the vector H. And there we go. So vectors' direction can be described in many ways. There are 2 different ways that you can do them that I like to look at. One is called a true bearing or an azimuth bearing. It's measured from north with an angle in a clockwise direction. So I'm going to draw north, south, east, west lines here, or Cartesian plane. I'm going to focus on the north. So you can draw something in these terms. Let's say I draw a vector down here. And from there, I'm drawing it in a clockwise direction. So going from here to here. So let's say this angle is, well, it's definitely bigger than 90. So 90 plus maybe 40 or something like that. So let's say 130 degrees. So you can describe it in terms of, so let's call this vector V. So vector V, let's find out the size of this thing, is 2.5 centimeters at an angle of 130 degrees. You can also use what is called quadrant bearings. So let me show you an example of quadrant bearings. So again, still north. Okay, let's draw a vector in the same kind of location as we did before. I'll even draw the same size. Now in this case, this angle right here was only 40 degrees down from the east line. And it's headed towards the south. So this vector, I'm going to call this vector U. This vector U can be described as 2.5 centimeters, east 40 degrees, headed towards the south. Or, if you wish, you can even describe it as 2.5 centimeters, south 50 degrees towards east. Either one would be fine. Now, you'll find out most of the time they do describe things in terms of the north-south line, but you can choose the east-west line as an option as well. Okay, some more terminology. The angle between two vectors is the angle less than or equal to 180 degrees, formed when two vectors are placed tail to tail. So let me show you an example here. So let's draw a vector headed this direction and another vector headed in another direction, but the two tails are put together. So the angle in between them turns out to be this angle right here. Here you can see the angle between it is less than 180. If the two lines were parallel and headed in opposite directions, then the angles would be 180 degrees exactly. If they're headed in the same direction, then the angle in between turns out to be 0 degrees. Okay, so an Iraqi militia group is spotted at 12 kilometers at north 21 degrees east, and a U.S. Marine Corps group is at 10 kilometers north 34 degrees west. Draw vectors to describe the location of these two groups and include the angle in between the two vectors. Whenever you're asked to draw these kinds of things, you don't have to be exact with the angles, but try to be a little bit more accurate with the angles as best as you can, and use your ruler to be accurate with the sizes. So let's draw this kind of thing here. Because both of these are focused on the north, east, and west lines, I'm going to try to minimize the amount of south that I see. Okay, so first off, the Iraqi militia group is 1.2 kilometers. So I'm going to draw something that's 2.4 centimeters. And I think that's an angle of 21 degrees. Going from north towards east. Because it's the Iraqi militia group, I'm going to put a capital M for its location. Starting from a starting point, let's call it O for origin. The other vector is a little bit larger, actually less. So I'm going to draw that at 2 centimeters, but at a larger angle, so 34. And the U.S. Marine Corps group, so I'll call this point U. So there's our two vectors. The angle in between is equal to 34 degrees plus 21 degrees, which is equal to 55 degrees. And there we go. There's the two vectors being drawn. And again, if you want, you can list the vectors. So the vector OM is 12 kilometers at north 21 degrees east. And the vector OU is 10 kilometers at north 34 degrees west. And there we go. And thus concludes lesson 6.1.